Alright, in this video I'll be exploring BIM for a bit. I was asked for a BIM engineering position to create a case study in Revit. Revit is expensive, I don't have it. And well, the funny thing about the case study was it had absolutely nothing to do with BIM. It is so very misunderstood. So yeah, we're gonna dive into it a bit. So here I'm opening Freecad, I'm going to the architecture/BIM workspace, and I created an IFC project, and I'm creating a sketch to lay out a master sketch basically that will hold the level, holy damn, the ground plane, the ground floor. So what I found out was I'm trying to do it with the IFC native tools. Couldn't get the hierarchy to work the way I wanted it, so I went back to just making a regular style hierarchy with a site, building, ground floor, and different levels. And I'm creating one sketch as a master sketch that I will use to base a lot of the other sketches from. I do that a lot, I find it very convenient. And now I'm I copied it, or I used it as a reference, and I'm building a sketch around it to use for the slab, the concrete slab, the main slab of the building. Yeah, back to the room for a bit. So blah blah blah. So what does BIM actually mean? BIM basically just means more data in your model. In the old days, when people build stuff, they make drawings on paper. It's like 2D lines. Gotta ring up a bit of a fever here. Basically they just draw 2D lines on paper, like top views, side views, that sort of thing. And then those lines moved into the computer with computer aided design or CAD. Still 2D, still drawn lines. Then they moved on to 3D models, and 3D models is where it gets a bit more interesting, because then we can make everything look like it is in real life, right? But yeah, there's still a lot of manual labor involved in getting all the data from those models, like for example how many meters of pipe you have, or how many bricks you need, or how heavy something is. All those calculations still have to be done. So the idea of BIM, building information modeling, is basically that you attach a lot of metadata to your models, and that they automatically calculate all those values for you. For example, insulation value of a certain type of wall, or how heavy something is going to be, or where the center of gravity is, or well, yeah, those kind of things. And yeah, engineers love lists. God, team leaders love lists. They make lists about every little thing. But yeah, I'm getting lost in thought here. So basically they think BIM is the answer to everything, but yeah, all that BIM really is real world metadata attached to your models. So next slide. So why do companies love BIM so much? Well, they think it's going to save them energy and time and money. And it would if it's used properly, but well, they don't understand what it is, so nobody uses it as it should actually be used. So it could save time because you don't need to manually extract or calculate all the data that I just said. But because the model itself holds all the data, and theoretically you should be able to hit a button, and the model just spits out lists with all the stuff that you need. And boy, engineers and team leaders in particular, they sure do love their lists. So yeah. In practice, however, stuff gets copied over again and changed a little bit, and you have to check and recheck and manually redo work all the time. And it doesn't save you time. If anything, it just gives you more work, because you have to redo stuff all the time that you wouldn't have to do with a old school 2D drawing. So yeah, if you don't do BIM properly, you're not saving any money. You're just ramping up your engineering hours. Yeah. So how is BIM actually supposed to work, and how would it benefit engineering? Well, BIM by itself wouldn't, because it's just moving work that before you had your model, or your 2D drawing, and then your model, and then you had all your calculations and your list. That was separate work, and you did them, well, you wouldn't do them combined together automatically like that. With BIM, basically it moved all that work from making lists and getting all your data to the model itself, but you still had to input all that data anyway. So if you would keep everything properly BIM, as it gets passed around different teams, at some point these teams are going to have to re-input data again, because everyone uses different software and every software has their own kind of format, and it never really plays nice with one another. So how would you make BIM work for yourself? Sorry, this is a fun thing. When I was making this project, at some point my sketch broke, so I had to go back in and fix it. Remove a few constraints, and I'm snapping it to, I think it was 10 millimeters to the outside of the wall here, or it's 10 millimeters from the inside, so 20 from the outside. The walls are 30 centimeters thick. So I'm fixing that here. I have two levels. I have a ground level, I have a first level, I have a second level, which is basically the ceiling and the roof. And I'm only doing the first level in this project. It was a test. I was trying to get BIM working as well as possible. So back to how you would make BIM actually work. Well, not if everyone uses different programs, and the solution is definitely not everyone just you go to a different engineering company and we want you to do an engineering package for us, but you have to use this software, and everyone has to retrain, and not that that's so difficult nowadays, but what you need are formats that every software can use, like natively, and that's where IFC comes in. So BIM is basically, you put real world metadata to 3D generated models, so that you basically get a digital copy of your real world model with all the same features and characteristics. And then you do proper asset management, so you don't have to do double work all the time. You don't have to redo your list, your calculations, you don't have to do, team leaders love lists, and I could rant way too long about that. So what I'm doing right now in the drawing is I have made a copy of the master sketch, and I put points in there that will help me easily place where all the windows and doors go. And the doors have to be a certain height, and the windows, well, I'm just moving up a little bit, and I'm struggling a little bit here because, well, I've never used this in Freecad before. I've done one small tutorial in the BIM workbench, and right now I'm just learning as I go. I mean, I understand the idea and stuff, but I actually wished I understood better how the IFC native file work, because that's what you want. Ideally you want native IFC, and you want as many applications as possible to use native IFC. So you finish your part of a project, and then you hand it off to someone else via an asset management system that everyone knows how to use and has the right kind of clearance levels and such. And then everyone can work in the same master structure, so to say. Native IFC, not locked behind a proprietary paywall from some software from some shady company. And IFC is actually not just a file format, it's also more of a philosophy, as in that it sets standards for how a project should be set up. At the root you have a node, which is your project. After that you have a node, which is your site, and after your site you have a building, and inside the building you have different levels and different systems. Each level has different rooms. Going to my notes again, each room has different elements, different furniture. Each system have their own subsystems. Say if you go more like plants and stuff, machinery has their own pipelines, etc. So you can go very deep with it, and there are best practices, and it's a huge topic. And if implemented well, it can save you a lot of time. Here I'm making an internal wall. This is supposed to be a stairs room and an elevator room. So I'm still modeling the ground floor. Small elevator building. I'm not making the elevator, I am putting the stairs in here. and then a little door underneath where the stairs is. Still fiddling a bit with the best way to move it, and for some reason the railings don't move with them. They don't look good anyway, so I remove them. And yes, I know it's not a good place to put the stairs like this. You should have like a platform before the stairs. Maybe I don't put a door up there. I have like that part. It would be an open area, so it's very clear to see where the stairs start. I don't know. And yeah. What was this? Oh yeah, I'm adding an extra door. And adding that extra door broke the sketch that the wall is referencing to, so I'm going to quickly fix that as well. There you go. Distance fixed. Alright. I'm putting in one more internal wall here. Copy the master sketch over, and then I also needed the position of the windows because I wanted the wall to be in the center. Because why not? So you have one big wall for a small office or meeting room. And for some reason symmetry didn't work. I wanted to symmetrize it between those 2 points, so instead I just use an old-fashioned diameter. And I didn't want to waste too much time adding points again for the door, so instead I use a different snapping setting. And oh yeah, I also forgot to, or I already fixed it here. Like part of my sketch, you've got construction lines and regular lines, and the construction lines don't do anything and the regular lines do. So initially for the inside wall I had all the copied lines over, they were still green as well, so I made them all reference lines real quick. And now the inside wall is fine and doors are fine, and I'm making one final wall here with the door. I'm constraining the length and all that. So yeah, this is the inside of the first floor. Just a quick mock-up I made. Second floor, I'm not finishing that. And now I'm moving on to a new building. So as you can see, the project has a site, it has an office which is building, and it has a hangar which is also building. I'm making a new master sketch for the hangar. I'm making a distance. I wanted to line up with the center of the main building. So I referenced that and I put it in the middle. I don't remember how I did it. I don't think it was with symmetry, because symmetry is easy to, that's a constraint that's easy to break actually. I love it, I love using it if it works, but if it breaks, it's yeah, I just use dimensions and make sure that you can be dynamic with dimensions as well. If you use like you make a variable or you use a spreadsheet and you just put the dimensions in there, it's not that hard. Here I'm using a different workbench. There's Freecad has a whole bunch of workbenches. The frame forge one, in which I also use a sketch, and I put a, what kind of beam was it again? I think an HEA 100 or 120. No, 140. An HEA 140 beam. And I have 5 of those and I space them 5 meters apart. And then I wanted trusses on top of that. And I tried to do it with a sketch that had 5 lines. That didn't work. So instead I kept those 5 lines as a master sketch and I just reference them all the time and I snap the other sketch to it. Because I also need to offset for the, oh no, that's later actually. So I have a truss here, I'll make it thicker, I'll make it bigger. So it's not so skinny. Then I use an array, and this is a bit where it gets tricky. I don't know if this is still BIM, if you still get all the smart data, like the trusses independently from the BIM workbench. Yes, they should have all the BIM data, like the material and the weight, all that good stuff. But if you throw it into an array, I don't know if it actually keeps it as, like from 1 truss all of a sudden to 5 trusses, if it keeps all the BIM data, or like it duplicates it by 5. We do have 6 pieces I think. Or 5, don't care. Now I'm moving it, I'm snapping it to place, and I need to actually snap the sketch itself. And now I use another array for the beam. And then I use one more array to make beams everywhere, and then I need to line it up. Could do this very exactly, but this was a very fast thing. I didn't want to, yeah, close enough is good enough in this this time. If I would put more detail into this, or more time actually, I would make it as exact as it should be. But right now the main goal is just to make it look good, make it look plausible, and not be too weird. I mean, I've seen some weird ass models. So I make another truss. This time I make the truss taller, so it's basically more of a side and a support structure. And there you have the hanger. I'm not going to put a wall on it, roof I mean. It's just an open structure for now, this is fine. Alright, one last thing is there's a rebar tool. So I'm putting rebar in the floor from the hanger. This is my template, which I use to make pages. I made a folder for pages as well underneath the file. And I make some views. And I notice in that view it's like, hey, damn it, the doors are not in there. So I make sure to select everything that I really want to see in there. And I make the views again. And yes, this time the doors are in there. But now the view is from the wrong side. So select it again. And this time the view is right again, and the windows and the doors are in there. So I delete the first group and I kept the second one, and I move stuff around and then I lock their positions. Another funny thing you notice with a lot of CAD people is that CAD is also a bit to blame for this. When you, it can be very convenient when you want to plot something out. You have a few of these options, like you want to plot the layout, you want to plot the window, the extents and all that. And then people tend to just drag and select the region they want. So you have your nice template, your frame, your page frame. But then they completely select the wrong size of the page frame, and one, it throws off your scaling from your drawing. And it's not wrong to set it up right, just set up your frame around the page with the correct margins in either model space or paper space, wherever your own preference is or your company's preference. And then just set it to layout, and you don't ever have to bother with that again. Like you just make the page, make sure that it has the right template of the right size, and just use layout. You never have to worry about the scaling being off, or yeah. Here I am fumbling a little bit because the points are a bit too thick. I'm gonna try and see it. This is the first time I've done this in this detail. And there's a setting for this, I just didn't bother to fix it. This is a door I placed randomly, so the values are not that pretty. These are a bit prettier, these values. Elevator door, stairs room. Tech drawer also automatically snaps your dimensions. You can also make chain dimensions. There's an option for that, but just do it manually. Well, not manually, but one at a time. And then make some annotations. Annotations are also fairly smart, as in they're little blocks and they're clear to distinguish and understand. They're not like random pieces of text that you copy paste around and then, you know, some are annotative and some are not, and then you start to move and scale, and all of a sudden you have a lot of different text sizes in your document. No, TechDraw is a pretty nice, yeah, TechDraw is nice. Doesn't have everything yet that I'd like, but it has quite a It helps you keep a lot of things consistent, which is really nice. That's a big issue. That's something that you could also, like, a lot of companies, I think, want to keep all their engineering consistent, all their drawings in the same style and the same kind of standards, but yeah, all their documents and standard work instructions are outdated, and everyone just uses what they're used to and iterates a bit on what the person before them did. It gets messy rather quickly. And you need to try to avoid that. You need to try to keep everything as clean as possible. Most important thing is that a drawing is easy to read, so that other people can use it to build stuff from. Standards are cool and all, but nobody really sticks to it in the end anyway, and the main thing is that whatever you're drawing has to be able to be built. Here I'm just filling in some of the titles. It has a few automatic fields. I do like that. It was a bit of a fidgeting to find out how to do that. But the title block has a lot of data which is automatically pulled in there. Okay, new page from the hanger, for the hanger. Now I thought, this page is actually a little bit too big for this. I don't need an extra view. I don't really need a detail view here. Well, don't need. I mean, this is obviously not a real project. If you were to build this, you would focus on the individual frame, and you would put a lot of details on there. But that would maybe I'd stick that on a different page altogether. And here I'm trying to change some settings to get those points a little bit down so it's easier to snap. Didn't get the right one yet. I'll look this up later and see if I can find whatever value is right. What I also like here is a tech draw actually snaps to like the other views next to it. I remember in Cadmetic I had to draw helper lines and then just snap all of my dimensions to that helper line if I wanted them to be at the same level. This is just so much nicer. And I'm trying to get another detail view in here because why not? Dumbass detail. I also forgot to hide something. You can see the beam has a little line running through the center of it. That's the sketch where all the beams are attached to. Should have put that to invisible. Okay. Looking for some other options. And saving out the PDFs. You can also see on the left that I have okay. Too late. Well, you can see the structure.